So example number 3 is saying to make a force diagram of an eraser resting on a ramp. So you can kind of think about the demonstrations lab that we did when we had an eraser and it was on the ramp. Again, does not need to be a masterpiece. I'm just going to go ahead and draw an eraser sitting on a ramp. So I forgot to mention before we get started that the SID method is what we're using to help us remember all the steps to creating a force diagram, and I have just done the first step, which was to sketch the object, so I can go ahead and cross that off. The next thing I need to do is identify all the forces acting on this object. In this case, again, you can, unless we're not on Earth, we are on Earth, so we are going to always include gravity. And the next thing that we think about, or could put on our paper, is the fact that this object is not falling. Yes, gravity is pulling down on it, but there's something holding it up, and in this case, the ramp is holding it up. And the ramp is acting as a support force. So we can go ahead and put down support force. And that's all well and good. However, the ramp is kind of on an angle, and yet this object is still not moving. So there's something holding this up. If I were to put a ball on this ramp, it'd roll right down. If this ramp were made of ice, it would roll right off or slide right off. But it's not. There's something about this ramp that is keeping the eraser up. And the answer would be friction. Friction is keeping this eraser from sliding down. It's keeping it right up at the top, just like you saw in the lab. And so we want to make sure that we get friction in there as well. That's it. It's not moving, so it's not going through the air. There's nothing stretchy or bouncy. There's no ropes involved. There's no humans touching it. So there are no other forces acting on this object. This object is not moving, therefore it is at rest. If an object is not moving or is at rest, it's going a constant speed of 0. So therefore we know that our forces are balanced. So gravity, support force, and friction are all going to be the same size. So the most important thing here is really the direction and then making sure that all of our arrows look like they're going the same size. So gravity, we should know this by now, is going down always. Support is usually going up, so we can go ahead and counter gravity with support force. And in this case we have friction. Well, friction goes opposite the motion of the object. If, again, circumstances were different, this object would slide downward. However, it's not. It's staying up, and that's friction that's keeping it up. So we're actually going to use this little diagonal up arrow to represent friction based on the way that I have drawn my ramp. If your ramp was going the other way, then friction would be going up the other way. But I'm not, because my ramp is not going that way. So all of this work is well and good. However, this is our force diagram, and so far all we've done is sketch the object. So I need to identify the forces on my force diagram. So I'm going to go ahead and write in my forces. Now these are vocabulary words, so we should be spelling these forces correctly. I can go ahead and cross off that I've identified, and now I'm going to put in the arrows. And remember, our arrows are going to be the same size. So I'm going to have gravity going downward. I'm going to have support going upward. And I'm going to have friction kind of going to the side. And all of those should be exactly the same size. And you want to make it as close to the same size as possible. I'm not going to take a ruler and measure it. However, when things are different, that's why I'm saying to exaggerate it. That way, when they are the same, they look the same. So I have now drawn my arrows to the correct size and direction. So I am good. I now have a complete force diagram.